All right, today in bell work, we're finally getting to that point in the year where free response is going to become more difficult. Okay, we're now able to do a full free response question. We really couldn't until now. Okay, until we could start doing Riemann sums and doing some integrals, we couldn't do it. Now we're in the baby steps. We're not getting full questions yet, but we're closer. Okay, up until now we've done like part A and part B, and I've faked part C's and D's, but we're going to actually get to that now. Okay, this was a question. It was on the AP exam a couple years ago. We can go parts A, B, and C here by the end of today. Part A, okay, it says grass clippings are placed in a bin where they decompose from 0 to 30. The amount of grass clippings remaining in the bin is modeled by A of T. Okay, so the amount of grass clippings is A of T, where A of T is measured in pounds and T is measured in days. Part A says find the average rate of change of A of T over the interval from 0 to 30. What are we doing if we're finding average rate of change? We are finding the slope, the 2-point slope. So we need 2 points. I'm over the interval from 0 to 30. So what do you think my x's are going to be? 0 and 30. We're going to find the y values. To find the y values, I'm going to use my calculator. So I pull up my calculator. I hit y equals. I typed in that guy, 6.687 and 0.931x. And then I'm going to cheat since I already have it typed in. I'm going to go alpha F4, Y1. I'm going to plug in 0. See what I get? 6.687. That is my x value. And then I want to plug in 30. So same thing. Alpha F4, Y1. I'm going to parentheses 30. I'm plugging in 30. I hit enter. How many decimals? 0.783 is going to be my value. 0.783. If I want to find the average rate of change, what am I going to do with these 2 points? Subtract them. Y sub 2 minus Y sub 1 over, that's an 8, over X sub 2 minus X sub 1. You need to show that you did this. Even if it is a calculator problem, on this one in particular, anytime you find average rate of change, show your fractional setup. Okay? If you're struggling with typing stuff in, again, I like going alpha F1, and I like to type it in as a fraction. So alpha F1, and then I picked the fraction button. I'm doing Y sub 2, so that guy, minus that guy, and it's going to be all over 30, because it's 30 minus 0. I type it in, I hit enter, boom, there is my answer, negative 0.197. Negative 0.197. Indicate units of measure. What is this top stuff measured in? That's what I got when I plugged in to A of T. That is measured in pounds. So this right here on top, it is pounds. 30 and 0 are on bottom. What are this 30 and 0 measured in? Days. So it is pounds per day. Make sure you have the units. If it asks for units, indicate units of measure. I better put units, so it is pounds per day. That is the answer to part A. Questions on that one? Part B says find the value of A prime of 15. Oh, that's easy. It's a calculator question. So I am not doing that by hand. I'm going to use my calculator. So I'm going to my calculator. How am I going to find A prime of 15? Math 8. I hit the math button. I go down to number 8. And I'm going to type in dx. I'm going to type in my equation. So I'm going alpha F4. I'm picking Y1. And x is going to be equal to 15. I type it in. I hit enter. Boom. There's my answer. Negative 0.164. 3 decimals. Negative 0.164. It says, using correct units, interpret the meaning of the value in context of the problem. All right, so let's find that. We just took a derivative. What does a derivative tell you? The instantaneous rate of change. Okay, what did I start with? What is, I'm sorry. What does A tell us? What value? It's grass clippings is what I meant to say. The grass clippings. I'm sorry. The grass clippings. What happened to the grass clippings? The grass clippings decreased. Negative 0.164. My units are going to be pounds per day. The grass clippings, I know. The grass clippings decreased. Negative 0.164 pounds per day. Is that all I need? At. If we're talking about a derivative, it is at. I like this. We said at a moment in time. At t equals 15 days. Technically, it's after the moment midnight strikes on the 15th day. But at t equals 15 days is even easier. That's wrong. What I've put up there is wrong. Max, why is that wrong? Decrease in a negative. You don't want decrease in a negative. That's a double negative. If I decrease by a negative, I really increased. So just do one of those. Okay, you can either say changed by a negative or decreased, but that is my answer. What did you start with? Grass clippings. Okay, we started with grass clippings. Then we said, what happened to those grass clippings? Oh, we decreased. Then I said what the value was with some units. At t equals 15 days, we got to say at whatever time. That is how we interpret it. There's a lot there, but it's not that complicated. Make sure you can do that correctly. Questions with that guy? Cool. Part C says find the time at which the average. So understand what's happening. You got a bunch of grass clippings in a box. They're decomposing. Okay. Find the time, T, for when the amount of grass clippings in the bin. So how much the actual amount is equal to the average amount of grass clippings in the bin. When is the actual amount equal to the average amount? Because it's decreasing that whole time. So we want to find out what is the average amount of grass clippings and then figure out when it's equal to that amount. We don't know how to do that yet. That is what we're going to work on today. All right, here we go. So, again, in bell work, I said, or as I was passing out those papers, I said you got an 80% on a test, you got a 90% on a test, and you got 100% on a test. These are all test scores. What would I do if I gave you a bunch of test scores and I asked you to find the average of your test scores? You would add them up and then why 3? Because there's 3 of them. That's exactly what we're doing today. Okay? We are finding an average value. Okay? That's what we're trying to do. It's as simple as add them all up and divide by however many you got. Okay? We talked about this the other day, so I'm not going to talk about it again. But remember what we're doing. When we find an integral, like if I integrated something, what we're going to find is the change in whatever one level above what you have is. So, for example, in bell work, if I were given the rate of grass clippings, when I integrate that, that will tell you the amount of grass clippings. Okay? That's what we're trying to do. Let's do this problem. Mr. Schwanenkamp, I'm driving my car on a road trip to Florida. I start at noon. I got bored and started to track my velocity in miles per hour every hour. So I started at 3 p.m. I look down at my speedometer. I'm going 64 miles per hour. Then I drive another hour at 4 p.m. I look down at my speedometer. I'm going 70 miles an hour. At 5, I'm going 72. At 6, I'm going to 72. Cool. Okay. We're going to use 3 subintervals. I say trapezoidal sum. Let's just act like I said LRAM. It doesn't matter. That's not going to be exactly right. I did this lesson before when I'd already taught trapezoidal sums, and I haven't taught it yet. So just act like it says LRAM. And we got 210. Okay? So, in general, we integrated from 3 to 6 this velocity, and we got 210. That's what I'm saying. LRAM approximates the area under the curve. So I integrated from 3 to 6, and I got 210. Given this information, interpret what that means. What does it mean if I integrate 3 to 6 via TDT and I got 210, and we're going to include some units. Talk with your neighbor for a second. What does that mean? If I integrate from 6 to 3 via TDT, what does this tell me? Anybody have a good answer for me here? I integrated. What were the units on this thing originally? Miles per hour. I integrated miles per hour. If I integrate it, then it's going to tell me the change in whatever is 1 love above what I integrated. So if I integrated miles per hour, what is it actually going to tell me? Miles. Okay. So the change in miles is 210 from 3 to 6 p.m. Now, I'm saying it very robotic, but basically what that means is from 3 p.m. to 6 p.m., I drove 210 miles. We're going to always say the word change in there just so we get used to it, but that's what it means. Everybody understand what's happening there? I drove my car 210 miles from 3 p.m. to 6 p.m. That's what I got from integrating velocity. It told me distance. Great. Now let's interpret the meaning. What if I did this? Okay. I got that same value, that 6 to 3 part v of TDT, but then I multiplied it by 1 over 6 minus 3. Or I multiplied it by a third. What would that tell me if I took this 210 and multiplied it by 1/3? I'd get 70. It's what? That is the average. 70 is the average velocity over that time period. Average velocity, which is measured in miles per hour, which should make sense because 210, we just said 210 was in miles. And what does this 1 over 3 represent? Oh, I'm dividing by 3 hours. Oh, so yeah, it's miles per hour again. So guess what I did? I took the miles per hour, I added them up. That's what integrals do. I added them up and I divided by 3. That's how we find an average. If I want to know the average test scores, I added them up and divided by 3. If I want to know my average miles per hour, I added them up and divided by 3. That's going to tell me the average miles per hour.
Why wouldn't you divide like by 3 with a 7 rule instead of 6 minus 3 to like this out?
It would get you the same thing.
I know. Well, yeah, they're both divided by 3, but like, what if there were 4 7 rules, but it was still
It wouldn't matter because you're dividing by the amount of time. And so however much time is spanning is that's what we're going to divide by. Okay, it doesn't matter necessarily how wide each interval is. It depends on what the total amount of time passed. All right, let's do this. All right, so anytime we find the average value of a function, if you want to find the average value of a function, you're doing this equation right here. Okay, I'm going to integrate the thing you are finding the average of. So if I wanted to find my average speed or my average velocity, I integrated velocity. And then I divided by the span of the integral. Okay? So I integrated from 3 to 6. I integrated velocity and then multiplied by 1/3. So let's see what happens. The temperature in a room is given by this equation. This is the temperature in the room throughout the day. I want to find the average temperature of the room from 2 to 6. They gave me temperature. They are asking for average temperature. What am I going to do to find average temperature? Integrate it. From when to when am I going to integrate it? 2 to 6. That's what I'm going to integrate. I want to find average temperature, and they gave me temperature. Oh, I'm going to integrate that temperature equation. But just doing that's not enough. What else do I need to do with that integral? I'm going to multiply by 1 over 6 minus 2. Upper bound minus lower bound. Or in other words, 1/4. I'm dividing it by 4 because 4 hours are going by from 2 p.m. to 6 p.m. Type into your calculator, get an answer. Here's how I'm going to set it up. You can go alpha F1. If you just want to type this in, you don't have to mess around. 1 over 6 minus 2. Obviously, we could write it as 1/4, but if you don't want to make the mistake, then type it in that way. And then we want to integrate, so we're going math 9. I'm integrating from 2 to 6, and I'm typing in that equation. So my equation, 20 plus 5 cosine, and then it's pi over 12t. So pi over 12t. You could use the fraction bar there as well if you want to. I'm confident in what I typed in there. I typed it in, I hit enter. Boom, there is my answer. 22.387. What are the units going to be on that 22.387? That is degrees Celsius, because I found the average of temperature, so it's going to tell me temperature. That is my answer to that question. Everybody good so far? Flip it over. Example 3, find the velocity. Find the velocity of the particle. Okay, we're finding this velocity over the particle. Find the average acceleration over the time interval from 1 to 5. They gave me velocity, and they're asking for average acceleration. What do I need to do? That is one way of doing this. Let's find the derivative. So the first thing I should do is find a of t. What would this derivative be? What's the derivative of 60t? 60. What's the derivative of 4t squared? Do it. Find the average acceleration. Go. Here we go. So if I want to find the average acceleration, Jesse, what did you have to do to find the average acceleration? We had to integrate from when to when? 1 to 5. What were you integrating? Integrate acceleration. If I want to find the average acceleration, I'm going to integrate acceleration. What else do I need to do with this number once I get it? Times 1/4. Boom. There's my setup. I'm doing average acceleration. I integrate acceleration and then multiply by the fraction. What did we end up doing what did we end up getting there? 36. What would my units be? Meters per second squared. I'm adding a time when I take a derivative, so it is meters per second squared. That is average acceleration. There's another way of finding average acceleration, and the only reason we can do this is because they told me velocity. If they told me velocity, and I want to know the average acceleration, what could I do with velocity? I could find the average rate of change, right? What is the average rate of change of velocity? That's going to find the slope of velocity. What would the slope of velocity tell me? Acceleration. So look, I plugged 1 into velocity. I plugged 5 into velocity. I got this. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Oh, that is 144 divided by 4. That is 36. 56 and 200. That was measured in meters per second, and the 4 on bottom was seconds, or in other words, meters per second squared. They both end up doing the same thing. It's just a difference as what you started with. If you start with acceleration, add them up and divide by however many you got. If you start with its derivative, find the average rate of change. Both of them will get you the answer in the end. Let's go to the next one. Okay, a little bit tricky on the next one. Don't let it be overwhelming. In which of these intervals is there a C value for which the Y value is the average rate, is the average value over the interval? Okay, so read this again. I know it's weird. There's got to be a value for C, so the X value, where the Y value is going to be is equal to the average value of F. This is a graph of F. How do I find the average value of F given F? Average value of F. We just did it. How do we find the average value? They gave me F. I want the average of F. What do? Integrate it. Good answer. Integrate it from when to when? 0 to 6. I'm going to integrate F. And then what else do I need to do with that? Multiply by 1/6. Find that. You can do it. You don't need a calculator. Just using your brain. Go. We are finding this. If I want to find the integral, that means I'm finding the area under the curve. if I'm doing that, you can break this shape up however you want. I'm going to break it up like this. Here's a rectangle. What is the area of that rectangle? 8. It's 2 by 4, so this is 8. I've got a little baby triangle right here. The area of that baby triangle would be 2. And then I got this big triangle. This big triangle has got a base of 4 and a height of 6, so that's 24. But you cut that in half, I get 12. What is this going to be? What is the average, or what is the integral going to be? 22. I've got to multiply that by 1/6. So I'm going to go ahead and get an answer to that. It is 3.67. Is that correct? 3.67. Cool. This right here is the average value. I want to know, where is there an x value where the y is equal to 3.67. So in other words, you are going to graph 3.67. Go on your graph. Make a line at 3.67. Draw it across. Is there anywhere where my function is equal to 3.67? Yeah, right here. On what interval of time is my function equal to 3.67? Is it from 0 to 2? Is it from 2 to 4? Or was it from 4 to 6? 2 to 4. It is right here in between 2 and 4. That is the answer to that question. It's a weird question. Okay? I understand if you read that and you're like, that is really weird. Yeah, it is. But it's just asking you to find the average value. And then when are you equal to that average value? Let's try one more. Okay, this is a free response question on the AP exam. A pot of tea cools. The temperature of the tea is modeled by H. So this is temperature. Okay, it's measured in degrees Celsius. Use the data in the table. So this is not necessarily what we learned today, but this is really important. They're going to ask this question on the AP exam. Use the data in the table to approximate the rate at which the temperature of the tea is changing at 3.5. Show the computations that lead to your answer. I want to know the rate of temperature changing. What am I going to do with temperature if I want to know the rate the temperature is changing? Find the derivative. If I want rates, that is derivatives. So what I want to find is the derivative of h prime, at 3.5. I want to find the derivative at 3.5. But all they gave me was a table. I can't find the derivative of a table. What could I do instead? Approximate it. How am I going to approximate that? Yep. Here's 3.5. It'd fall right here. So if 3.5 is going to fall right there, what number should I use instead? 2 and 5 and 60 and 52. Approximate the rate of change. See what you can do with your neighbor. Go. Andrew, how did you approximate h prime at 3.5? Found the average rate of change. He's got two ordered pairs here. 2, 60 and 5, 52. He found the average rate of change. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We get negative 8 over 3. What would my units be there? What is that 52 and 60 represented in this thing? That is degrees Celsius, and the 3 represents minutes. It is degrees Celsius per minute. Boom, that is my answer. Show the computations. That just means do this. If you showed that, you're good. Let's look at one more. Using correct units, explain the meaning of 1/10, 0 to 10, h of TDT in context of the problem. It says use a trapezoidal sum. Let's not do that. Let's go RAM. Use RAM with 4 subintervals indicated in the table to estimate that. Okay, that's going to be your homework for this evening. Figure that out. Okay, use RAM to find the area under the curve, multiply it by 1/10, and then explain what that means. Go.